Welcome to the session on effective fraction instruction for students with learning disabilities. My name is Jung. My colleague and I will share with you some ideas of supporting children's understanding of fraction. Development of students' understanding of fraction is an important goal of elementary school mathematics. This involves developing equal partitioning strategies, understanding the meaning of fraction symbols, representing fraction in multiple forms, and comparing and ordering fractions. Formal fraction instruction begin in the third grade. However, it is highly suggested to support their development of informal understanding about fractions before third grade, emphasizing equal partitioning strategies for two-dimensional shapes. The Common Core State Standard emphasizes understanding of the meaning of the fraction symbol, equivalent fractions, comparing fraction with different denominator and numerators, and solving fraction problems that involve addition, subtraction, multiplication, and division. It is no longer a secret that fractions are one of the most challenging areas in school mathematics. Unfortunately, data from the NAEP assessment have consistently shown that our students have a weak understanding of fraction concept. For instance, the data for this NAEP question shows that only 43% of fourth graders were able to find fractions that accurately represent the leftover pizza on the picture. Fractions have represented a considerable challenges for children with learning disability. This may also impact their learning of more advanced mathematical areas in later elementary and secondary school. They have difficulty with making sense of fraction symbols and interpretation. How can their learning of fraction be supported? Many children have misconceptions about fractions, most of which come from their limited understanding. For instance, they often create fractions where the numerators and denominators are representing two separate whole numbers as shown in the example in which a child incorrectly recognized 1/3 as a half. To support their learning, three common fractional models have been widely used that include area model, length model, and set model. With an area model such as pattern block, a fraction can be shown as a part of an area of the whole. With a length model, the length of a part is compared to the whole length instead of area. Number line, Kugeneral rod, and fraction strips are considered as length model. In a set model such as two-color counters, a whole consists of a set of objects, and fraction can be represented as a subset of the whole set. Before using this model, we must ask, are any of these models more appropriate than the others in some context, and why? Considering this question, we must intentionally select and use our fractional model. For instance, with each of these three fractional models, we can show fractions using at least two different methods, part-whole method and comparison method. In the part-whole method, fractional part is embedded in the whole, while the comparison methods show fractional parts and the whole separately. One challenging part of the part-whole method is that they must be able to see part and whole simultaneously. When using this pattern block, for instance, they must see the rhombus not as an individual quantity itself, but also as a part of the whole. If they cannot think of these two quantities and the relationships at the same time, the part-whole method may not be the best way to show fraction. Let me give you an example. Each fraction here is represented with the part whole method. And you can see how some children's inability to see fractional part in relation to the whole could cause them to make such a mistake. On the other hand, the comparison method may be more effective when we try to help them understand the need for common whole, such as this example of adding fraction with a different denominator. Research has indicated that area models have been exclusively used in many schools. They have found that their experience with the area model is very effective for area model tasks. However, they also have found that many students could not transfer that knowledge to fraction problem in non-area model context. Children need to have experience with a different fraction model because it really helps them develop a more comprehensive understanding of fraction. It is also important that teachers include a variety of situations in which fraction can be shown with a different fractional model. To support children with learning disabilities, instruction must be more explicit and strategically scaffolded. For instance, recent research studies investigate a new framework called VRA and found its positive impact on fraction learning of children with learning disability. Here is the list of references that might be useful for teaching fraction. Thank you for attending our session, and we hope you have a great conference.